look at finding the area of a circle and how this formula was derived. So I have two pictures here, and I'm wondering, what do you see, think, or wonder? You can pause the video here and think about this. All right, welcome back. And now, if you look at this picture, you'll notice that in the top one, I cut my circle into sectors that are equal sized, and I arranged them below. So the blue are on the top, and I have my yellow at the bottom. And you'll notice that they make a figure. What figure is that? You're right, it's a parallelogram. Now notice that the radius of my circle is the height of my parallelogram. Just a reminder that the radius is any point from the center of the circle to a point on the outside of the circle. Again, the radius, same as the height. Now notice that the circumference is the distance around, and half of the circumference is equal to the base of my parallelogram. If you want to review how to find the area of a parallelogram, please use my QR code to see my video on that. All right, so now looking at these two pictures again, we're going to find the area of the parallelogram based on the circle. So remember, to find the area of a parallelogram, you need to multiply the base and the height. So the area equals base multiplied by the height. So since we know that the base is 1/2 of the circumference, we can replace the b with 1/2 c. And we also know that the radius is what the height is, so we can replace the h with r for the radius. Now, if you think back to what you know about circles, you should know that the circumference of the circle is pi multiplied by d, the diameter, or pi multiplied by 2 multiplied by r, or we say 2 pi r, because 2 multiplied by r, 2 radiuses, is the diameter. Since we know this c equals 2 pi r, we can replace the c in my formula with 2 pi r. Now, since we're looking at 1/2 multiplied by 2 is 1. So half of c equals pi r. So a equals pi multiplied by r, and we can simplify this to a equals pi r squared. Now that we have our formula, we can use this to find the area of different circles. So let's do some practice. For the first one, I have a radius of 5 centimeters. So I will write my formula, area equals pi r squared. And just a reminder that pi is about 3.14. Notice I don't have an equal sign. It looks like a little squiggly equal sign, and that means about or approximately. So now I can replace my pi with 3.14 and my radius with 5. And notice that I have the 5 centimeters in parentheses and then squared. Order of operations, or GEMMA, says we must do exponents before we multiply. So I will do 5 centimeters squared first, and the area is about 3.14 multiplied by 25 squared centimeters. And now I multiply and end up with about 78.3 square centimeters. Now this one has a diameter of 12 centimeters. Again, the same formula for the area of a circle, area equals pi r squared. But since it's the diameter, we need to cut it in half because the radius is half of the diameter. So the radius is going to be 6 centimeters. So I replace my pi with 3.14 and the radius with 6 centimeters. Again, I'm going to square it first. So 3.14 multiplied by 6 squared is 36 centimeters squared. And the product is about 113 and 400 square centimeters. I hope that helps with how you can find the area of a circle and also how you can, how we derived the area of a circle formula.